Okay, so besides selection, projection, and duplicate elimination, these operators, in this page we can show you with two other operators we can use, and we can implement them with a one-parse algorithm and by loading data into memory. The first one we have is called grouping. I hope you still remember grouping, right? So, this grouping can be implemented in SQL by the keywords like group by and having, right? Something like that, if you still remember them. So, in this page, we show you with the example. We do a grouping as denoted by the gamma, and we have city and some price on a relation. The physical meaning denotes given a relation on some cities, we can have some price for the housing, right? And the operator we're doing here is to group all the records, all the tuples in the relation according to the cities. And we try to calculate the price of a house price inside a city. We calculate the sum of the price. So in other words, we are grouping according to the city, and for each group, we try to calculate the sum of all the price in the houses inside the city. Alright, and so the result will be also one relation. We have two columns. The first column is the city. The second column denotes the sum of the price of houses inside the city. Right. As the rows of the result by this operator, it depends on how many number of cities we can have for this relation. Alright. Okay, so to define or to implement this operator with algorithms, we may need to keep a dictionary in the memory as well. This dictionary can keep a records for each city. What will be the sum of price of the records or tuples inside the relation? In other words, the key for the dictionary will be the city, and the value of the dictionary will be the sum of price of houses in the relation R for each of the city. And so we need to store both the city as well as some price for each city in the memory, right? As to the cost for this operator, it will be about BR, right? In other words, we have to go over all the tuples in the relation R. So we'll be able to access all the city of the tuples and all the sum of all the price together. The cost will be about BR, right? If this R is clustered. Also, we have an assumption because for this operator, the result will be, the size or the number of rows of the result where it will depends on the number of cities we have in the relation R, right? So we have an assumption. In other words, the number of cities will fit in the memory. Or we can say the number of cities is no greater than m of the memory for holding one tuple or one result into one block in the memory. Right? So we have some assumption and requirements for implementing this operator with a one-parse algorithm. Besides this operator, another operator we want to show here is for the binary operations. So given two relations R and S, we can calculate the intersection, the union, as well as the difference of these two relations. So you can imagine how to implement these algorithms, these operators with one parse algorithm. And normally when we are implementing these operators with one parse algorithm, we have some assumption or requirements. It is denoted by the mean of BR and BS is no greater than m. This BR denotes the number of blocks for storing this R, right? It's denoting number of blocks in this S. We need to ensure the smaller ones among these two relations, or the small number of blocks for storing these two relations, is no greater than the number of blocks we can store in the memory. This M denotes the blocks in the memory, right? The main reason we have the assumption because when we are implementing these operations with one parse algorithm, we use one buffer for use to read the blocks of a larger relation, while we use this m-1 buffers needed to host the entire small relations and its memory data structures. So in this way, for all the blocks in the larger relation, we can compare it with this the smaller relation to calculate its intersection, the union, as well as difference. For the cost of these operations with one parse algorithm, will be about BR plus BS. We may have to store all the tuples in these two relations into memory. So this will be about the cost for implementing these operations with one parse algorithm.